Good morning, everyone. Our topic of discussion is traveling salesperson problem using greedy strategy. So before proceeding to that particular traveling salesperson problem, we must know what is the problem definition. So let us start our discussion. So problem is traveling salesperson problem, applying greedy strategy. Actually, in this problem, a salesperson or a salesman needs to visit n number of cities. So what I am telling, in this problem, a salesperson or a salesman needs to visit n number of cities. N number of cities. Let me select it first. Suitable color code. Yeah, n number of cities. In such a manner that all cities must be visited at once. But I told, a salesperson or even a salesman needs to visit n number of cities in such a manner that all cities must be visited. All cities must be visited at once. Okay, and in the end, that salesperson returns to the city from where he started with minimum cost. So what I'm telling, a salesman needs to visit n number of cities in such a manner that all cities must be visited at once, and at the end, the salesperson returns to the city from where he started, but with minimum cost. The last part is very vital to remember, that is with minimum cost. Okay. Suppose a salesperson has to visit 10 cities, city 1, city 2, city 3, city 1, city 2, city 3, up to city 10. Suppose salesperson started his journey or her journey from city 1. So he or she has to cover from C1 up to C10 all the cities at once and finally come back to C1. That is from where he or she has started his or her journey. But as there may be different routes from C1 to C2 or C1 to C3 or C2 to C3, C2 to C4, whatever you say, as per the constructions of the city and the connectivity is considered. So definitely there may be a different possibilities of the routes which a salesperson can avail. But here one of the constraint is not only the salesperson needs to visit each and every city at once and come back to the city from where he or she has started his or her journey, but with minimum cost. So cost should be minimum. Cost means travel cost should be minimum. Suppose the cities are X1, X2, or even you can say C1, C2, whatever. As you have mentioned that total n number of cities are there. Suppose the cities are X1, X2 up to Xn, where assume that the cost Cij, that actually denotes the cost of traveling from city Xi to the city Xj. Okay, and the traveling salesperson problem is to find a route starting and ending at X1, because X1 is the starting city from where the salesperson started traveling actually. That's why it is told the traveling salesman problem is to find a route starting and ending at X1. That means moving this location, this, and coming back to X1. That will take all the cities at once, but with minimum cost. This is very vital to maintain. So what actually the greedy strategy suggests? Greedy strategy actually suggests that start with any arbitrary city, say x1. Start with any arbitrary city, suppose x1. So this is the first point. Start with, I'm repeatedly telling, start with any arbitrary city, arbitrary city. Start with any arbitrary city, say x1. Then choose the minimum cost city from x1. Choose the minimum, choose the minimum cost city from x1. Okay. Then greedy strategy also suggests at any step I, at any step I, we will be left with actually n minus I cities. We will be left with n minus I cities. And the method is repeated until all cities are visited, and at every step we have to select the city with the minimum weight. The last part is very vital. The method is repeated. The method is repeated until all cities are visited, and at every step we have to select the city with minimum cost. This is, I must mention here, at every step, we have to select the city. We have to select the city with minimum cost. And you have to repeat the procedure until all the cities are visited. And at every step, we have to select the city with minimum cost. The algorithm is very simple to understand, or the strategy applying the greedy method is very simple to understand. You have been given n number of cities, x1 up to xn. You have to start from an arbitrary city, suppose it is x1. You have to choose the minimum cost city from x1 in the very next step. And at every step, suppose I, we will be left with total minus I, that is n minus I cities. And you have to repeat the method, or the method is repeated until all the cities are visited. And at every step, we have to select the city with minimum weight. Or we can say the method is repeated until all the cities are visited. And at every step, we have to select the city with minimum weight. The entire procedure can be very clear to understand if we go for solving one very simple numerical using this traveling salesperson problem, applying greedy strategy. So let us go for solving one very simple numerical. As it is a traveling salesperson problem, so let us consider that a salesperson is waiting to visit n number of cities in such a manner that all the cities must be visited at once, and at the end, he or she returns to the city from where he or she has started, but with minimum cost. So let us assume that we have total 8 cities. And the cities are expressed as H1, H2, up to H8 respectively. The entire problem is represented using a graph, suppose. Suppose H1 is the first city, okay? And from H1, anybody can move to H2 with the cost 5 units. From H1, not only anybody can move to H2, but assume that anyone can move from H1 to H4 with the cost of 6 units, say. Then somebody can move on from H1 to H6, suppose, with the cost of say 4 units again, 4 units, sorry. Then assume that somebody can move from H2 to H3 with the cost of suppose 2 unit. Then somebody can move from H2 to H4. This one is H4. H2 to H4 with the cost say 4 unit. Anyone can move on from H3 to H4 with the cost say single unit, that is 1. Somebody can move from H4, suppose another city is H5 with the cost of 7 units. Somebody can move from H2 to H5 also with the cost say 3 units. Someone can move from H5 to H7 with the cost suppose 6 units. H6 to H7 with the cost suppose 3 units. Then H5 to another city which is left, that is H8 with the cost suppose it is 4 units. And H8 to H7 there is a path, that there is a there's an association from H8 and H7 with the distance say 2 units. And another association is from H8 to H1 and assume that it is 7 units. So this is the entire problem where H1 to H8 are the cities and they are of having their connectivity. Not all cities are connected to each other, but some of the cities are connected directly, some of the cities are connected via the other cities. Say for an example, H5 is not directly connected to H1, but H5 is connected via H2. H1 is connected to H2, H2 is connected to H5. So in this way, all cities are somehow being connected as per the graph is given. And the graph actually represents the entire problem where all cities are somehow connected in, among themselves by either directly or via, and the distances are also mentioned. Salesperson needs to be visited every city once, and assuming that H1 is the starting city. And salesperson has the responsibility to come back to H1 also, because starting city should be considered twice. Because from where the salesperson starts traveling from a particular city, suppose H1, unless and until he comes back to his or her own city, that implies he or she has to stay to other cities. But this is impractical. So from where we started our journey, we have to come back to there. So that's why the starting city must be visited twice. So if this type of problem is given, and as we have mentioned, what about the strategy, applying greedy strategy we formulated, this is very simple. I told you that select any arbitrary city at the starting city, choose the minimum cost city from that starting city. Then at any step, suppose n minus I cities are left. We will be left with n minus I cities, and you have to repeat the method until all the cities are visited. And at every step, we have to select the city with the minimum weight. This is our proposal to solve this problem. So how to solve this problem is very simple. So let us move back to the problem given. So first of all, we have to form the cost matrix to represent the entire problem, because cost of ij is very interesting here. Suppose cost of ij is basically the matrix where the matrix is formed in between city to city. So almost we have altogether we have 8 cities. So the cost matrix will be 8%. H1, H2, H3, H4, H5, H6, H7, H8. It is basically an adjacency matrix. Better to say it's a cost matrix where if there is a direct association, we have to put the cost. If there is no direct association, we just put 0 here. So H1, H2, H3, H4, H5, H6, H7, H8. So if I want to frame the first row is for H1. That means I am actually standing at H1. I actually want to find out where there is a direct association from H1 to other vertices. H1, there is no self-loop, so it is 0. H1 to H2, yes, there is an association. H2 is direct adjacent of H1, so we have to put the cost here. This is 5. H1 to H3, there will be no direct association as per the problem statement given, because Here it is actually assumed that I am currently at city number 1, that is H1. If I want to travel H3, that is third city, I have to travel from H1 to H2, then I can travel from H2 to H3. This is one of the alternatives. Another alternative is also possible, but I am showing currently one alternative. So there is no direct association between in between H1 and H3. So the value put into the matrix, value to be put into the matrix is basically 0. H1, H4, yes, 6 unit, this one. So we have to put 6 here. H1 to H5, no direct association, so we have to put 0 here. H1 to H6, yes, this 4 unit, so I have to put 4 here. H1 to H7, sorry, there will be no direct association, so we have to put 0 here. And H1 to H8, yes, there is an association, that is 7. As it is an undirected graph, H1 to H8 has the same significance as H8 to H1. So please be careful because it is not a directed graph. So here H2 to H1, yes, that cost is 5. H2 is 0 because there is no self-loop. Then H2 to H3, yes, it is 2 unit. H2 to H4, yes, it is 4 unit. H2 to H5, yes, it is 3 units. H2 to H6, it is 0. H2 to H7, it's a big 0. H2 to H8, it is also 0. So, sorry. So let me come back to the previous slide again. So sorry for this interruption. So it's a 0. Now I am going to fill up H3. H3, the row that I'm going to fill up, that implies I am at right now H3, then I have to find out the adjacency from H3 to other vertices. So H3, H1, it's a 0. You please verify it. Once you can solve this problem by your own, kindly verify it. I can formulate it now. H2 to H3 to H2. Yes, it is 2 unit. Then it is 0. Then it is 1. Then 4 not, no association. Then I am jumping to H4. It is, if I'm not wrong, it is 6. H4 to H1. Yes, it is 6. H4 to H2, it is 4. H4 to H3, it is 1. Then 0. Then 7. Then all 3 are 0. Then H5 to H1, it's a 0. H5 to H3, it is a 3. Sorry, H5 to, yes, H5 to H2, it is 3. H5 to H3, it's a nil, that is 0. H5 to H4, yes. H5 to H4, yes, it is 7. H5 to H5, it's a big 0, no self-loop. H5 to H6, H5 to H6, no, sorry, 0. H5 to H7, yes, it is 6 unit. H5 to H8, yes, it is 4 unit. So remaining 3 rows I am filling up. My student, kindly verify it whether it is right or wrong. And if it is wrong, please rectify. I'm sorry, if it is wrong, please rectify and solve accordingly. If I'm not wrong, 0, then 3, then 0, then first 4 not. Yes. Then yes. Then it is 6. Then it is 3. Then it is, yeah, itself it's a 0. Then it is 2. Yeah. Then it is 7. 0, 0, 0. Yeah. 4, 0, 2, and not. So this is actually the cost matrix. Once you perform the cost matrix, the problem is almost solved. So as I told that select any one of the arbitrary city as the starting city, assume that H1 is the starting city. So we have to come back to H1 after all other cities have been visited once. So we are now at H1, fine. So we are here. So we have to scan H1 row actually and identify the city having the minimum cost from H1. H1 to H1 is 0, so no need to consider. So you have to identify the non-zero entry and identify which one is the minimum non-zero entry. Minimum non-zero entry 5, 6, 4, and 7. Among these 4. So which is the distance from H1 to H6? Yes. So I started from H1. That means being a salesperson, I started from H1. Then I move on to H6 because this is the shortest distance from H1 to comparing H1 to other adjacent. We have found that H6 is the minimum weight holder. So H1 from H1, if anybody starts, if any salesperson starts. So first of all, you will move on to H6. Okay. So this is the local minimum actually. So now you are at H6. So from that current one, you have to identify the minimum cost city from the current one. From the current one means you are at now H6. You have to scan the row of H6 and identify the non-zero entry, which is the minimum non-zero entry among all non-zero entries present in that row. So one non-zero entry, that means you can travel from H6 to H1, and you have the option to travel from H6 to H7. But among these two entries, value 3 is the minimum. So you have to travel from H6 to H7 because 3 weight is for H7. Okay. So from H6, I'm moving from H7. So I'm right now, I'm sorry, very sorry. Coming back to the board again. So now I am at H7. This is my current city where I am currently standing as a salesperson. So identify the non-zero entry. These 3 are the non-zero entry. Among these 3, 2 is the minimum. So 2 is the minimum cost, where the city is actually H8. So from H7, I am moving to H8. Okay. Then I am right now at H8. This one is non-zero entry. Among these 3 non-zero entry, 2 is the minimum. 2 is the minimum, that is 2 is the minimum. So that is identify the city number. Identify the city number. 2 is the minimum, but the city number is H7. But H7 is already visited. I cannot visit one city twice because except the starting city. So H7 is not the starting city, so I'm helpless. I cannot visit it twice because if I visit it twice, then it forms a cycle. So yes, it is not accepted at all. Once the city, except the starting city is visited once, you should not consider it further. So this one is cancelled. So next find another minimum. Next minimum among 7 and 4, it is 4. So identify the city, and the city is nothing but H5. So H5 has not come yet. So from H8, I have to go for H5. Very simple. Then I am right now at H5. Scan the row H5. H8 is already covered. Scan the row H5. Identify the non-zero entry. This one, this one, this one, and this one. Among this 4, 1, 3 is the minimum. Yes, identify the city. Identify the city means H2. H2 is not yet come. So I can freely move to H2. Yeah. Now I am at H2. Then identify the non-zeros. Among these 4 non-zeros, 2 is the minimum. Identify the city. Yes, H3. H3 is accepted because H3 has not come yet. So H3, I am right now at H3. Identify the non-zeros. Non-zeros means 2 and 1. Among these 2 non-zeros, 1 is the minimum. Having the city H4. H4 has not yet come, so I can travel from H3 to H4. Fine, now I am at H4. Then I have to come back. I have to identify who is the minimum. Who is the minimum means in this row, these are the non-zeros. Among these 4 non-zero, 1 is the minimum. 1 is the minimum. The city is H3. H3 is already covered, so you cannot take H3 further because H3 is not the starting city. Then the next minimum is 4. 4 is the city holder H2. H2 has been covered. So you cannot reconsider H2. Then the next minimum is 6. Yes, the city is H1. Yes, you can consider Yes, you can consider H3 to H4 I have gone, then and then yes, you can consider H1 further, H4 to H1, because all other cities have been covered exactly once. So we have total 8 cities. 1, 2, 3, 4, 5, 6, 7, 8. Last one, including it is 9. Yes, I should include it because I have to come back to the starting city again back. Okay. So what is the distance? H1 to H6. H1 to H6, it was 4. H6 to H7, it was H6 to H7, it was 3. Then H7 to H8, it was 2. H8 to H5, it was 4. H5 to H2, yeah, how much it is? It is 3. H5 to H2, yeah, it is 3. H2 to H3, yes, it is only 2. Yeah. Then H3 to H4, it is a unit distance, that is only 1. Then H4 to H1, H4 to H1, yeah, it is 6. So altogether 4 plus 3, 7, 7 plus 2, 9, 9 plus 4, 13, 3, 16, 2, 18, 1, 19 plus 6, it is 25. So this is the minimum cost, including the starting vertex twice. This is the minimum cost, including the starting vertex twice. Okay, very simple. The problem is represented with the help of the graph, showing all the cities along with their connectivities, and the age weight indicates the distance traveled from city 1 to city 2 or even city 2 to city 3, whatever cities you are considering. So first of all, form the adjacency matrix between the cities. If you have n number of cities, the matrix will be n cross n. And the row numbers are the city numbers and the column number are also city number. Assuming that no city in the graph structure, that is no node in the graph structure is of having the self group. So principal diagonal of this matrix will be 0. Then whenever you are constructing first row, that is for the first city, identify the adjacent cities, put their distance in the appropriate field if there is an adjacency, otherwise put 0. If two vertices are adjacent, then put the cost. If they are not adjacent, put 0. Principal diagonal definitely means 0, considering no self group present for any vertex or any cities here actually. Then select any arbitrary city as the starting city. Here we have assumed that H1 is the starting city. So we start scanning row number H1 and identify the non-zero entry, and then identify which one is the minimum non-zero entry. Identify the city from the column. So for an example, when we are at H1, we have 3 non-zero entries, 5, 6, and 4. If I consider 5, this is the distance from H1 to H2. If I consider 6, this is the distance from H1 to H4, because under column number H4, 6 belongs. Then if I consider 4, this is actually H1 to H6. So among these 3, 4 is the minimum. So I have to travel from H1 to H6 at first. Then my current city is H6. Then I have to come to the row number H6. Then I have to start scanning the entire row, identify the minimum non-zero entry, identify the city, appropriate city against the non-zero, minimum non-zero entry. Then you have to verify whether this city has already been visited or not. If it is not, you can consider it. In this way, you have to consider all cities exactly once except the starting city, because you have to come back to the starting city. So starting city will be repeated twice. And the other than starting city, all the remaining cities will be visited only once. So put the cost and calculate the sum. That is the minimum cost traveled by the salesperson from the starting city and coming back to the starting city. Again, considering the remaining or other cities exactly once. So this is actually the traveling salesperson's problem. So what is the actual path here that we can notify by changing the color code here? So actually H1 to H6. So this one. Okay. then H6 to H7, this one, then H7 to H8, yeah, this one, okay, then H8 to H5, this one, then H5 to H2, yeah, this one, then H2 to H3, yeah, this one, then H3 to H4, this one, then H4 to H1, right? Okay, so this is actually the way that a salesperson travels so that he or she can visit the other cities except the starting one exactly once and come back to the starting city. You will find that this one done first time, this one 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 first time. Yes, this one now second time because it was the starting city. So just as a recapitulation to solve this problem, the greedy strategy which you have proposed here, you have to start with any arbitrary city, say it is H1, say it is X1, whatever the nomenclature you use. Choose the minimum cost city from the current one. Okay. So initially it is from the starting vertex. At any step I, we will be left with n minus I cities, and the method is repeated until all the cities are visited. And at every step, we have to select the city with the minimum weight or the minimum cost, whatever you say. So this is actually traveling salesperson problem using greedy strategy. My students, it is one of the assignment that you can try. Suppose you have total 5 cities, and suppose V1 is the first city. Suppose, sorry, V1. Suppose V1 here. V1 is the first city. Suppose it is V2. V2 is the second city. Suppose it is V3, the third city. Suppose it is V4, fourth city, and suppose it is V5, fifth cities. And these are the association V1 to V2 with the cost 19 unit. V1 to V5, suppose the cost is 22 unit. V1 to V3, suppose the cost is 19 unit again. Suppose V1 to this one V4, and assume the cost is 25 unit. Then V2 to V3, suppose the cost is 21 unit. V2 to V4, this one, suppose the cost is 23 unit. V2 to V5, suppose the cost is 21 unit. Suppose, yeah, V4 to V5, assume the cost is suppose 22 unit. V4 to V3, suppose the cost is again 21 unit. So altogether all have been covered. Okay, fine. Let us make a connectivity from V5 to V3 and assume the cost is 20 unit. Okay. V5 to V2 is already connected. This one is already connected. So assume that this is the graph given. That is where V1, V2, V3, V4, and V5 are the cities. So you better to consider V1 as a arbitrary city as a starting city and apply the greedy strategy to solve this traveling salesperson problem. I hope that you can easily get the result of this problem. If you want to refer the solution which you have made in the last slide, you can refer it, but kindly solve this problem. You can refer it, no issue. Kindly solve this problem and get the result. So this is what about traveling salesperson problem using greedy strategy. I hope you people have understood, you studied well, and solve this numerical. Thank you.